Hey everyone, Teacher Chang here, and today we are going to go ahead and talk about how do we convert standard, vertex, and factored forms. So let's go ahead and take a look at each of these forms here. All right, the first one that we have here is standard form, and the standard form has that format of y is equal to a times x squared plus bx plus c, where a is going to end up being a number, b is going to be a number, and c will be a number. The vertex form has a format of y is equal to a times x minus h squared plus k, where a is a number, h will be a number, and k will be a number. And finally, our factored form has the format of y is equal to a times x minus d times x minus e, and a, d, and e are all going to be numbers. So each of these forms has their own advantages, and we're going to take a look at each one. So we take a look at our standard form. The standard form has the advantage of telling us what that y-intercept is. So when it's written in standard form, that c value at the very end is going to tell us the y-intercept. So if we take a look at our example, y is equal to negative 2x squared minus 4x plus 6, well, that 6 is our y-intercept, meaning that we have a point located at 0, 6. Now the vertex form will tell us what the vertex is, hence the term vertex form. So the h and the k will tell us the vertex. That's the point in our parabola at either the very bottom or at the very top. So if I have a parabola opening up, that's going to be our minimum value. That's our vertex is at the bottom of our parabola. But if I have a parabola opening in a downward direction, well, that vertex is going to be located at the top, and that's what that vertex is. So the vertex is our h and our k value, which is this 1 and this 8. However, the h is going to be the opposite of what it says in the equation. So if you notice that the h value in this case is going to be negative 1 as opposed to a positive 1, and the k value will remain as is. So the h value is always going to be the opposite of what it says, and the reason why is because we have this minus sign in our vertex form. So we got that minus sign, meaning it's going to be the opposite. The factored form, the d and the e, will go ahead and tell us what the x and intercepts are. But it's not always just the d and the e. There might be a number in front of these x's, and when we have a number in front of these x's, well, we need to do a little bit of work here. So in this particular case, where we have our y is equal to negative 2 times x minus 1 times x plus 3, well, that negative 1 and that 3 will help us determine what our x-intercepts are. And if you haven't noticed, well, they happen to be the opposite. And the reason why they happen to be the opposite is because when we're solving for our x-intercepts, that means the y value must equal to 0. Which means, well, in order for this to be 0, well, that means we can set our x minus 1 equal to 0 or x plus 3 equal to 0, because anything times 0 is equal to 0. So if I set x minus 1 equal to 0 to solve for x, I'm going to add 1. So that's going to give me x is equal to 1. But if I want to go ahead and set x plus 3 equal to 0, I'll do that right here. I'm going to subtract 3 on both sides, and that's going to give us negative 3. So our x-intercepts, if we were to write that out as an ordered pair, the x-intercepts are going to be located at negative 3, 0, and at 1, 0. So each of these forms has their advantages. The standard form will tell us what the y-intercepts are. The vertex is the vertex form, obviously. The vertex and the factored form will go ahead and tell us what the x-intercepts are. So let's go ahead and start off by converting our standard form into our factored form. Now our standard form and our factored form is something that we've learned in the past, and all we're doing is we're just factoring. And when we want to factor, I'm going to take a look at this first one here. I noticed that the leading coefficient is 1. And when the leading coefficient is 1, if I can factor it, I can go ahead and write out these parentheses and just put in these x's here. That's going to get me my x squared. X times x is x squared. Well, to figure out the rest, what I'm going to do is I'm going to go ahead and figure out what are factors of this last number. So factors of negative 35, yet at the same time, it has to add up to negative 2. So I want to know what are factors of negative 35 whose sum is negative 2. What times what is negative 35 that adds up to negative 2? Well, if you think about it, 7 times 5 is going to get me 35, but I need a negative 35. And yet at the same time, I want it to add up to negative 2. So that's going to be, that's right, negative 7 and 5. So I'm going to put in that negative 7 here. I'm going to put in that positive 5 here. We'll go ahead and bring down that y. And what you have is the factored form of that standard equation. So our factored form here is y is equal to x minus 7 times x plus 5. All right, so what happens when we do have a number in front of that x, like this 2? Well, if you do have a number in front of that x squared, what we need to do is we need to multiply that first number with that last number. So we're going to multiply these out. 2 times negative 15, well, that's going to give me negative 30. So what we want to do is we want to find out what are factors of negative 30, yet at the same time, I want it to add up to that middle number, negative 7. So what times what is negative 30, yet at the same time, it's going to add up to negative 7? Well, that's going to give me negative 10 and positive 3. Negative 10 times 3 is negative 30. Negative 10 plus 3 is going to give me negative 7, so it works out. Now what we're going to do here is we're going to take this 2x and we're just going to put it underneath it like as if it was a fraction. So I'm going to put that 2x underneath the negative 10 and I'm going to put that 2x underneath the 3. And like any other fraction, we got to simplify our fractions. So that negative 10 and that 2x, they both can be divided by 2. So that negative 10 is now going to give me negative 5. That 2x divided by 2, that's just going to leave me with x. Now when I write out my factors, I'm going to go ahead and always write out my x term first. So here in this first set, I have my x minus 5. The second set I can't simplify, so I'm just going to go ahead and write the 2x first. So that's 2x, and I have a positive 3, so that's plus 3. And then I'll just bring down the y equals. So right here we have our factored form for 2x squared minus 7x minus 15. So we've learned how to factor. We've learned how to go ahead and convert a standard form into factored form. But what if we wanted to go ahead and go from factored to standard? Well, I'm just going to go ahead and FOIL. FOIL means where you multiply the first terms, the outer terms, the inner terms, and our last terms. So what we're going to do is I'm just going to FOIL here, and I want to go ahead and bring this right back to what we started from. We want to bring it back to this y is equal to 2x squared minus 7x minus 15. So I'm going to go ahead and work backwards. So the first thing that I'm going to do here is I'm going to go ahead and FOIL. I'm going to get rid of all of that. And we're going to go ahead and check our work. We're going to FOIL. So I'm going to distribute that x. So x times 2x is going to be 2x squared. And x times 3 is going to give me 3x. When I'm done distributing that first term, I'm going to distribute the second term. Negative 5 times 2x is negative 10x. And negative 5 times 3 is negative 15. Now once I have all of that, I could go ahead and combine my middle terms, which is negative 7x. I'll bring down that negative 15. I'll bring down that 2x squared. We bring down the y equals, and what you should be able to see is that this is the same thing as what we first started off with. 2x squared minus 7x minus 15. So we have both the factored form, so standard to factored, we did that earlier, and then we could go ahead and check our work by FOILing or distributing one term at a time, and that'll just bring us back to standard form. Okay, so we know how to convert standard to factored, factored to standard. So now what we're going to do is we're going to convert vertex to standard form. Now there's a few ways that we can do this. One of the easiest ways to do this is to go ahead and just do order of operations. And what we're going to do is we're going to go ahead and do this part in parentheses here. So I'm going to do that x plus 1 squared. Now, the x plus 1 squared, we could do it one of two ways. We could go ahead and just separate them and do that x minus h times x minus h, or we could go ahead and take the square of a sum or the square of a difference. In this case, it'd be a square of a sum. So I'm going to go ahead and do both, and you can choose which method you want to do. So if I were going to go ahead and do this x minus h times x minus h, because it's squared, I can go ahead and do x plus 1 times itself. And we're just going to FOIL like we did earlier. So I'm going to go ahead and distribute that x. X times x is x squared. X times 1 is x. And then we'll go ahead and distribute the second piece, the 1. 1 times x is also x, and 1 times 1 is 1. And if we combine the middle terms, we got 2x's here, so 2x. We'll bring down that plus 1. We'll bring down that x squared. So we just did the x plus 1 squared. Now that's this portion here. We're going to bring down that 3, and we're going to bring down that minus 2. Okay. So now that we've done that, we're going to go ahead and multiply. We're going to multiply this 3 with everything inside the parentheses. So 3 times x squared is 3x squared. 3 times 2x, 6x. And 3 times 1 is 3. And we'll bring down that minus 2 again. Well, then we just combine our 3 and our negative 2. Oops, wrong one. Go ahead and get rid of that. We'll combine our 3 and our negative 2, and 3 and negative 2 gives me 1. Okay, we'll bring down the plus 6x. We'll bring down the 3x squared, and we'll bring down that y equals, and we now have converted our vertex form into our standard form. So that's one way to do it. Now I'm going to go ahead and do this again, except I'm going to go ahead and do it by doing a square of a sum or a square of a difference. So I'm going to erase all of this really quickly, and we'll go ahead and take a look at this other method. And again, you get to choose which method you want to do. I really don't care how you do it as long as you can do it. So let's start off by doing that same piece first. We're going to start off by doing our x plus 1 squared. Except we're going to go ahead and do the square of a sum. Now here's a quick trick about it. We can go ahead and take that 2. Oh, wrong one again. Let me go ahead and fix that. We're going to take that 2, that little 2, that exponent, and we're going to go ahead and give it to the x, which is x squared. And we're going to give it to the 1, and 1 squared is just 1. So that's going to give me my first and my last terms. Well, to get that middle term, a nice simple way to do it is just multiply straight across. X times 1 is 1x, and 1x times 2 is 2x. And there you have it. We got our trinomial now. Now all of this is still going to be multiplied with that 3, and we still have that minus 2. So from this point on, everything's the same that we did earlier. So I'm going to go ahead and distribute that 3. 3 times x squared is 3x squared. 3 times 2x is 6x, and 3 times 1 is 3. We'll bring down that minus 2 again. We'll combine our like terms. So that's going to give us positive 1. Bring down the 6x, bring down the 3x squared, and we'll bring down that y equals, and once again, we have our standard form. So that wasn't too bad. So we now know how to convert vertex to standard form. So let's go ahead and do it the other way around. Let's do standard to vertex. Now if we want to do standard to vertex form, we got to do a little bit more work. So changing from standard to vertex form, we need to figure out, well, what is that vertex? Because we want it in vertex form. So if I need to figure out what is that vertex, I need to go ahead and do this formula right over here. X is equal to negative b over 2a. Now that's going to give us our x value. And once we get that x value, we're going to substitute that x value into the equation and solve. And that's going to give us our y value. So let's start this off. I need to figure out what is a, b, and c. Well, a is 2, b is 12, and c also happens to be 12. So I'm going to go ahead and copy down that formula. I always copy down that formula. So x is equal to negative b over 2a. And we're just going to substitute everything. Now I need to figure out, well, what is b? Well, b, we stated, is 12. And anytime you substitute, you're supposed to put it in parentheses. And then we have our a. A is 2. And now all we got to do is the math. Well, negative times 12 is just negative 12. 2 times 2 is 4. And well, negative 2 over 4 is negative 3. So we now know that x is equal to negative 3. So now I'm going to take that negative 3 and I'm going to substitute it into my equation anytime I see an x. So I'm going to recopy that equation. And when I recopy that equation, anytime I have an x, I'm going to replace it with a negative 3. So y is now equal to 2 times x, and we just stated that x is negative 3, squared, plus 12 times x, and again, negative 3. And then we have our plus 12. So we just substituted that negative 3 in for x. Now that we have this, we can just solve it by doing the math. So I'm going to do this portion first. Negative 3 squared is 9, and 2 times 9 is 18. Then we'll go ahead and do the middle portion. 12 times negative 3 is negative 36. And then we have that 12, and I'm just going to bring that 12 down. So plus 12. All of this is still equal to y. Okay, so now all I got to do is add those together. 18 minus 36 is negative 18, and negative 18 plus 12 is going to give me negative 6. So now I got y is equal to negative 6. Now this right here is going to give me my vertex. I now know what the vertex is. The vertex is going to be our y, our x, which we said earlier is negative 3, and our y, which we just found out, is negative 6. Now this is our h and our k value. So we're going to take what we have here and we're going to substitute it right into our equation. Y is equal to a times x minus h squared plus k. So I'm going to go ahead and write that out. So y is equal to a. Well, what is a? A we found earlier. That's 2. Times x minus h. Well, h is negative 3. That's this one right here. Well, minus a negative means it's a positive. So positive 3 squared plus k, and well, k is that negative 6. So minus 6. So what we have now is our vertex form from our standard form. All right, I hope this helped out. And if you have any questions, leave a comment.